In this demo, I will focus on how we can consume Generative AI Hub in Python as alternative option in addition to the JavaScript development. So you will see that in the Python code, we will build the prompt differently with respect to what we showed in the Node.js demo. This is to showcase more advanced functionalities from the Generative AI Hub SDK and LangChain. So let's start the inspection of the Python code we have prepared. It's a very simple Python class made of a certain number of methods. We will inspect only the most relevant ones. As usual, at the top, we import all the needed packages and libraries. And we can notice there we are loading a couple of functions from the SDK and also from LangChain that we will use in a second. Let's start from the initialization of the Python class. Here we see the first function, setProxyVersion, taken from the Generative AI Hub SDK. This function provides a convenient way to create a proxy to your AI core instance where the models are deployed and initializes the model endpoints. The setProxyVersion makes use of the AI core credentials taken from the service key generated in the BTP cockpit. Basically, these credentials can be provided with a specific config file or by setting proper environment variables. Now, let's have a look at the lines below. Here you see we are using the second function taken from the Generative AI Hub SDK, that is this init LLM. This is one of the available functions provided by the SDK to initialize the abstractions to the chat model endpoints. In particular, this is to initialize the LangChain abstraction to the OpenAI chat model endpoint. Here we are assuming we want to use an Azure OpenAI model, that is GPT-4. But you see that we are simply passing the label that identifies the model in Generative AI Hub. So in case we want to switch to another Azure OpenAI model, the only thing we need to do is to change the label here. For example, we could switch to GPT-3.5 by simply passing this label, GPT-3.5 Turbo. And it's up to you if you want to customize some of the model parameters. In any case, once the model is initialized, you can invoke it on your prompt, but we will see better this step in a minute. Now let's focus on the code. So as you can see, it's very concise, but I can show you the lines of code you would have had to write to consume your models without Generative AI Hub SDK. The use of the SDK basically avoids to take care of the authentication of the header and the payload preparation and the preparation of the API call to the model itself. Not to mention the fact we don't need to check the deployment ID of the specific large language model we want to use in AI Core. So there is a great benefit to go with the SDK. In case we want to switch to an open source model, for example to Falcon, you would have to slightly change the syntax here. For Falcon, we can use the OpenAI-like API, more suitable for a completion model like this. Also in this case, we need to simply provide the name of the open source model in Generative AI Hub and eventually to set the parameters. Let's now move on and focus on the lines of code responsible of encapsulating the citizen message into a convenient prompt. Here you can see the dictionary you have already seen in the previous demos, containing the guidelines for the model on how to extract every single information we need to get from the post. Here you can see I create a template for the prompt to submit to the model. The template is super simple and it just asks to extract information from the social media post. The placeholder that you see here, named post, will be replaced by our citizen message at runtime by LangChain, because from this string we will build a so-called LangChain chat prompt template that helps managing list of templates messages to generate the final prompt in a more convenient way than playing, for example, with strings. So how do we specify exactly which information we want to get from the post? To this end, we can use the so-called OpenAI functions, a new functionality provided by OpenAI recently. So Certain OpenAI models like GPT 3.5 or GPT-4 have been fine-tuned to detect when a function should be called and respond with the inputs that should be passed to the function in an API call. You can describe the functions and have the model intelligently choose to output the JSON object containing arguments to call those functions. We can profit from this functionality to get the information we need from the social media post in a more controlled way, since we are going to use GPT-4. In order to do that, we define a function to retrieve certain properties from the post. And we define the properties we want, taking them from the dictionary we prepared earlier. So the model will output exactly a JSON with this required information. Let's notice we are making use of an enumeration to place a constraint on the values the model can choose. Moreover, please notice we are specifying that the category and priority are strictly required for us, and indeed they cannot be missing if we want to create a maintenance notification in S/4HANA Cloud from the information extracted by the large language model. Before, we have said that it's possible to initialize our large language model endpoint to use any other model available in Generative AI Hub, like Falcon, for instance. But if we choose Falcon or another open source model, we have to notice that some parts of this code could need some rework, might need to be changed, since, for example, the functions are only available for some GPT models. The power of LangChain in general is to compose chain of components together. And here, in order to execute all the operations needed in our Python application, we want to go exactly with this approach. We make use of LangChain expression language and chain all the operations together with a Linux pipe syntax. And we input this chain to the model. I've written a method named askLLM where I build from our prompt template a LangChain chat prompt template, and I define the sequence of operations we need to execute as a chain. Please notice that the output of each step is input for the next one. So basically, we start preparing the prompt, then we use the bind command to pass to the model the needed parameters, in this case the function we defined previously. And then implicitly we require to inference the model with our prompt. And finally, we use the JSON output parser to parse the output into a JSON format. At this point, the chain is executed, as you can see, by simply calling this invoke method. Finally, the askLLM method returns the response in a JSON format.